And then this is the furnace. So I'm just gonna unload the furnace. You can unload the sample, or you can go to furnace and go down. They'll both lower it and you can unload it. If you hit unload the sample, it'll move everything and open it for you. So however you want to think about it, lowering the furnace first and then unloading. So the biggest issue we're having right now is when you've ran your tests and it was at 1,000 degrees Celsius, sometimes the hang down wire doesn't release from your pan a little bit. So just be kind of ready, and I'll explain why it's important after this one shouldn't do it because it wasn't actually hot, but waiting there. So the pan is going to come down slowly, and then the wire should drop. Do you see that quick drop there at the end? If the wire doesn't drop, if the wire comes down and then it stays on it, it's going to start moving this way. The pan's going to be on this, and then it's going to bend the hang down wire. So whenever it kind of does that, just have your stick ready, and then just a little tiny tap and it'll knock it loose.
Okay.
So that's all you got to do. When it comes down, the first thing it does, when this is at the down position and this moves over, the hang down wire will come down slowly and then it'll drop like a millimeter. If it doesn't drop, just tap it. Yeah.
Okay.
And it's not every time, so don't be a little overexcited on that, but
okay.
We don't want to bend the hang down wire. So this is a new hang down wire. We had to replace it because the last one was broken. They're $200 each, and the thermocouple is $1,000. So do your best to not touch this thing at all. And then we don't want to put any lateral forces on that hang down wire. The downward tap is only going to move a millimeter. If you tap it too hard, you're going to bend the hang down wire. Yeah. So just the tiniest little, babyest little nudge. I usually have both my hands ready and just give it a little peck. So when you finish a run, we're going to have it go up to 1,000 degrees Celsius, so we don't have to clean our pans, but we are going to have to blast it with compressed air. So whenever I'm holding it to clean it for compressed air, I hold the pan itself and not the wires. These wires bend really easy. They're not steel. They're made of some funny alloy. So just hold the pan itself, and then you can dump out the ash in the trash can, and then I just put the pan up here in the fume hood. I turn the air on, and then I just get all the solids out of here. So you finish a run, you take the pan out, you blast all the solids out with the compressed air, and then we're going to put the pan back on here and tare the pan. This is the slowest step. So put the pan on there. Do you see these the wires? And then in the holder here, there's two little tick marks in there. So the pan will sit in those two little tick marks, and and then you see how this one's bent a little bit? I'm going to put it to where it's leaning this way, so it's not leaning away from the hook. So it's got a really narrow window. So now it's going to be leaning towards the hook, and then on the controls, I can either click the picture that says tare, or I believe you can do it in one of these, calibrate. There's a tare in the calibrate button, or just the symbol that looks like tare. So you click the tare button, it's going to load the sample for you, and then it takes around 5 to 10 minutes. It has to stop swinging. Every time you load the sample, so if you're tearing it or loading it, you want to make sure you're watching the furnace. So I'm not going to hit tare just because it takes 10 minutes. I'm just going to hit load sample. And then as soon as it comes out of the way, so if it was tearing, it would be the exact same. And then I'm going to hit furnace up in this case. So you guys would just press tare in your case. Biggest thing I'm going to watch out for is make sure this isn't swinging too much. If the pan is swinging a whole bunch when it picks up, just go ahead and stop it so it doesn't, and I don't think this button will actually stop it. Oh, it does, okay. So if this is swinging too much, and it only did it to me once, the pan will hit the furnace, fall into the bottom, or get stuck or whatnot. So just make sure that you're not hitting tare and walking away. We need to make sure that the pan goes inside the furnace and it doesn't get pinched or crunched or anything. So when you're doing a tare, this step here is about 10 minutes long, and it'll automatically lower when it's done. So once it's tared this, it'll take around a few minutes. Then you can load your material into the sample. Like we did this time, I usually just set it straight. I set the pan straight on the balance, but I'm using powder. So however you want to do, just tear the pan first, load the material onto it like we did this time. And I'll run through it again after we do it. You might want to take the video on. This would be fun to do the video on, I guess. And then let the arm pick it up. Again, we don't want to put any forces on the pan, so don't get impatient and try to like pick it off yourself. Just let the arm move it over. I was initially using tweezers to pick it up, but I think it's a little easier just to do it by hand and kind of pinch it. But that silver pair of tweezers would be the ones you should use if you're going to do it, because they don't shut. So, and make sure you don't lose any of your material since we have to walk so far. There we go. Once my material's in here, I go to controls, I press load, and then I press furnace up. So most of the stuff you're going to do is going to be in the controls. And I'm going to load the sample. It occasionally misses it, but for the most part, it usually gets it. If it misses it, it'll automatically come back and then try a second time. So you can
load the sample and now
see if it gets it or not.
Furnace, right?
Sir. There used to be a touch screen, so all this would be done on the touch screen, but the touch screen is taking a nap. So this is where you're watching it, and then if it dings the pan, and usually you can tell if it's shaking too much. This looks pretty stable, so that should be fine. All right. So I didn't set anything else up for you guys. Maybe could have done that, but what was the letters you just told me to use?
Bacterial cellular.
BC. Yeah. Okay. And then what do you guys want to call this one? Number 1 or?
Yeah.
Just test 1. And if you want to have notes, like if you have 3 or 4 different types and you want to have like repeats, you can write that stuff down here. Anything you write in these 2 blocks will be in the file itself, so you don't have to like write down duplicates of everything. Whatever you write here will be in there. Weird thing with this is I've got the sample name here. I also have to change the file name here. So if I want to change the sample name, I then have to click in the Explorer here, and then we made you guys a folder. So we'll call this one BC1. Is that good?
Yeah.
All right. So then you hit open, even though you're not opening it. So I changed the name there, and I changed the name there. And then I think this procedure should be one I just made for you guys. Yes, the custom one. I forget how to. So the procedure, we're editing it over here. So these will, anything you write in these will show up. Just make sure you change the name and make sure you change the file name. So that is the general setup. If you need to adjust the program, and I'll just explain what program I have in here. It's selecting nitrogen, or it's selecting the first gas. We have air and nitrogen as the 2 gases. So it's going to select the nitrogen gas, it's going to turn the flow rate on, it's going to sit for 15 minutes and do absolutely nothing. So right now you can see the readout of the scale. The scale is going to like sway and bounce around when you first raise the furnace. So I have a 15-minute period where nothing is going to occur. After that period of time, it's going to start recording data. It's then going to raise at 10 degrees per minute all the way up to 1,000, and then it's going to switch over to air, and it's going to burn off anything that's left. And then we're going to sit there for 15 minutes at 1,000, and then the machine shuts off. The reason we let it sit under air, and you guys can not do this if we want, is we don't have to clean the pans afterwards.
Okay.
If you don't run it up to 1,000 degrees Celsius, if you don't go up to like 400 or 500 Celsius, it's not going to burn off all the organic material. And then if you run another test, there might be some lingering material. So you have to clean the pan entirely. Or what we're doing is just going way past what we think we need, and then we're introducing air for a couple of minutes, and it's going to burn off anything that's on the pan. So we're cleaning the pan at the end of the run. So if you want to do it a different way, we can.
No, it's
but
fine.
that's what I've been doing. Not to say I'm doing it right, but that should be working for us. So for each run, all you have to do is change the sample name and change the file name. You could leave, like I said, the sample name, but you have to make sure you change the file name, otherwise it's going to override the previous one. Once you've got everything loaded, you can just hit run immediately because it's going to go ahead and do the 15-minute dwell. So right now it's just starting a 15-minute timer is all it's doing. And then after that 15 minutes, it's going to start the run. And then you have an estimated time down here on how long it's going to take to finish. And it's fairly close to accurate because it's a 15-minute time, a 15-minute time, and then you have however many, 100 seconds, 100 minutes. It just adds all that together for us.
Awesome.
There's a folder tagged TGA. You can also right click and then click on the TGA folder there. Oops, I'm gonna remove that one. I did it again. There's two TGA folders. So if you click on this TGA folder, it'll bring you to the folder with all the results, and your test is in there now. So as soon as you hit start, it creates the file. Well, you don't have to verify it, but make sure that, like, so if you finish a result and then you're copying stuff over or whatnot, this one is the one we're currently doing. So if you're working on the computer, make sure you don't mess with, try to open that one or delete that one or anything, otherwise it'll kill your data. So you can use the other files in the folder, they're fine. Just if you're like copying and pasting to a thumb drive, make sure you don't mess with the one that you just started. There. And then it's really fun. If you click here, you can see all the information. So all the notes and everything you wrote will show up in here. Whatever notes you wrote in the comment section, they show up on there somewhere. The name of the sample. It even has what method was used. So if you guys change your method when you're testing different samples, you're struggling, bub. It'll show up right here. It tells you the total time and everything like that. So that's in the all text. If you close the program by default, it doesn't have that one clicked, so you can just you can recheck it and it'll be fine. So you open up a test that you did. You can view it by weight % over temperature. You click up here on the signal selection, and you can change it from temperature to time if you wanted, and see it over time. And oops, wrong button. So a lot of the times we're going to do the % weight loss versus the temperature that it was at. That's the more common version of looking at it. So you can look at it this way. You can add a second x-axis, but you can also just create multiple charts and save the images from those. You can click on the weight %, and I want to see it as a derivative of the temperature, and that will show you the time at which it had the most weight loss. So it's kind of steady. It had an increase in weight loss around 300, and then it steadily dropped back down, and it had a pretty steady drop after that. So this is the derivative chart, which is a really common thing to show, and then you have the normal. So this is all in the signal. So my material had 100% weight all the way up till here, and then it started to lose a weight as it was going, and then it's gradually leveled off.